Lesson 9, Day 2, writing an equation using slope and y-intercept. Read the problem below, then explore different ways to find the slope and y-intercept for a linear function. Tony's taxi charges $3 to pick up a passenger, plus $2.50 for each mile. Write an equation for the function that relates the total cost of a trip to the distance. Also, identify the slope and y-intercept of the function. Well, before I even look at the model it or the graph it, you should easily be able to tell what the slope and y-intercept will be. So we know for a fact he's going to charge you, or Tony's taxi is going to charge you $3 just to get in that taxi. That's the fee. Okay, so that's your initial fee just for getting in the car. And we're now calling our initial value, or our initial fee, we're calling it our y-intercept. And then we have plus, it literally says plus $2.50 for each mile. So we know we're going to be comparing the number of miles. That's going to go into our total cost. And we know how much each mile is going to cost because it says it's going to be $2.50 for each mile. That's going to be our rate of change, which we now call our slope. So we have our y-intercept and we have our slope. And of course, we know all of this is going to end up being the cost, the total cost of the trip, which is going to be our y. Each mile, our number of miles is going to be x. Our y is the total cost of the trip. The rate of change or slope is going to be $2.50 because it's $2.50 for each mile. And then, of course, our initial fee is our y-intercept, $3. And again, since we were given the slope and the y-intercept, we're going to use the slope-intercept formula. Again, we know our slope and our y-intercept. So our slope-intercept formula is y equals mx plus b. We know that our m is 2.50 because it's $2.50 for each mile. And we know our b is $3 because it's $3 just to get into the taxi. So we can go ahead and answer or plug in what our values for m and b into our slope-intercept formula. So we'll have y equals 250x plus our b, which is 3. And that should be our answer when we get done with this problem. All right, so moving on to go further into explaining this. The model it. You can use a table to find the slope and the y-intercept. So they start off with x being 0. Again, when x is 0, that's when you're going to find your y-intercept. Okay, your y-intercept is when x is 0. When x equals 0, y-intercept is the y value. So our y-intercept again is 3, which just further proves what we said in the beginning when we found our initial value and said that was our y-intercept. So that's true. Okay. Then of course, we can find our slope. So to find your slope, that's your rise over your run, which is the change in y over the change in x. So to get from one y to the next, we go from 3 to 5.5, which is adding 2.5. Then to go from 0 to 1, we add 1. So we've got 2.5 over 1. So our slope or rate of change is 2.5, which again, we already had. Okay, we already knew that because they told us that in the original problem, that they charge $2.50 per mile. All right, moving on, you can use a graph to find the slope and y-intercept. The point on the y-axis is 0, 3. Remember, your y-intercept is where your straight line, or where your line where it crosses the y-axis. Again, you have your y-axis here. The only point on the line that crosses this axis is here. And of course, the y-intercept is when x equals 0. Your y here is 3. So of course, your y-intercept was 3. Then here's a new way where you can find your slope, which I think you guys will really love. So our slope, again, like we talked about, is your rise over your run. See how far you go up and over to get to your new point, from one point to the other. To get from, let's try this point here. To get from this point, well, let's just choose an easier point. I'll choose a point that's like not in the middle, because I guess it could. I just don't want to. All right, so I'll just choose this point and this one. All right, so we'll go from, and this point is 2, 8. This one is 4, 13. Okay, so to get from 2, 8 to 4, 13, I'm going to go up and I'm going to go over. So I'll make a little triangle. So I've actually risen up 5 units, and I've gone over 4. I'm sorry, I've gone over actually 2 units. It's 4 halves, but it's 2 units. Okay, 2 full units. So then I'm going to say again, my slope is rise over run. I rose from one point to get to the other, 5, and I went over 2. So my rise over run, my slope, is going to be 5 over 2, which is equivalent to 2.5. Same thing that we've done before, but it's just a neater way to do it for our visual learners. This is very helpful. Okay, and I think we're all pretty much used to doing things with triangles, so this is pretty fun, a different way to look at it. Of course, you can always go back to your slope formula, which is y2 minus y1 divided by x2 minus x1. And you can still do the exact same thing. Choose any 2 points you wanted to. I'll make this one 0.1 and this one 0.2. To get from 0.1 to 0.2, we have our y2, which was 13, minus y1, which was 8, over x2, which was 4, minus x1, which was 2. So 13 minus 8 is 5, and 4 minus 2 is 2. So either way, you would get your 2.5. So we've got 2 ways to do this. We can use our rise over run and just kind of draw it out and then simplify it. Remember, always simplify. Or you can just go back to the basics and do your slope formula. y2 minus y1 divided by x2 minus x1. Either way, you get the exact same thing. All right, moving on to the questions. Connect it. Write an equation for the linear function on the previous page. Explain how you, and again, we already had this. So we had y equals 2.5x plus 3. Okay, explain how you can use a table or a graph to find the slope, and what does the slope represent in the table? I'm sorry, in the problem. So you can find the slope in a table by finding the change in y divided by the change in x. Okay, and then you simplify, which is exactly what we did here in this table. We figured out how to get from one y value to the next, and then we figured out how to get from one x value to the next, and we just did rise over run to find our slope. So we found the change in y and divided by the change in x. And when I say change, all I'm talking about is this, what we did. How we got from one y value to the next. How we got from one x value to the next. That's all we're doing, okay? And then we simplified and got 2.5, okay? In a graph, what we did to find the slope, and we did that on the previous page as well, we did rise over run. You figure out how to get from one y value to the next. So we chose 2 points. Then we said, well, we're going to rise up 5 and go over 2 to get to our next point. And so then we did that again. Rise over run, 5 over 2 equals 2.5. We also use the slope formula. Okay, so you have a couple ways you can do that. So you can draw out the rise over run, draw it out, or use the slope formula. Okay, which was our y2 minus y1 over x2 minus x1. All right, and then of course, what does it represent in the problem? Our slope represented the cost per mile. Okay, that's all it was. And I don't have any more space, so I'll write it over here. That was our cost per mile, was our slope. All right, moving on to number 3. Explain how you can use a table or graph to find the y-intercept, and what does the y-intercept represent in the problem? So a table, how you're going to find the y-intercept is when your x value equals 0. What is your y value? Okay, when your x value equals 0, your y value is your y-intercept. Okay, and a graph is where your line crosses the y-axis. And here, our y-intercept actually just represented the initial cost or the fee just to get in the taxi. Okay, so our y-intercept represented the initial fee. The initial fee for the taxi ride. All right, number 4, in the equation y equals mx plus b, which value represents the slope? Again, slope-intercept, we can go back to where I started this video. So our m, of course, is going to represent our slope, which was 2.5. And of course, our b represents our y-intercept, no matter what. So the slope is our m, and our y-intercept is our b. All right, use the information from the previous page and above to write an equation for this linear function. We already did that, so you just kind of copy it down here. You could have also just left off the 0. That's fine. If you were one who used a fraction, yours could have looked like this. And that's fine as well. They're all equivalent, so I'm okay with that. All right, and number 6, check your equation by substituting x with one of the x values from the table, and do you get the same y value shown in the table? So let's go up to the table and check it. So let's use 2. Okay, we have our equation. Again, this is a good way to check to see if your equation is correct. Does it match what you were given? So let's say y is going to equal, of course, 2.5x plus 3. And what is y when x equals 2? Okay, so y equals 2.5 times 2 plus 3. Well, 2.5 times 2 is 5 plus 3, y equals 8. So we just found that y equals 8 when x equals 2. Were we correct? Yes, we were. In the original table we were given, when x equals 2, our y should equal 8, which means that our equation is correct. Yes, it did match. Yes. Okay. The triad. Hopefully you've already done this. Go ahead and check it now. What is the slope and y-intercept of this equation? Super easy again. When you have the form of the slope-intercept form, all you're doing is identifying here the slope and the y-intercept. M is always your slope, which is your coefficient, and B is your y-intercept, which is your constant. Our coefficient here is 3/4, so our slope M is 3/4, and our y-intercept, our y-intercept, oops, I should write B first because they asked us that. Our y-intercept is 5. All right, moving on. Number 8, write an equation for the table of values and explain how you got your answer. Again, one of the easiest things is since you were doing the slope-intercept formula again, we're going back to filling out this exact same equation. So we have our y equals something x plus something, okay? We just need to fill in these two values. So we can first, the easiest thing I always want to do first is to find our y-intercept, because again, when looking at a table or a graph, your y-intercept is going to be when your x value equals 0. What's your y? Well, in our table, when our x equals 0, our y was 2. So our our y-intercept is actually going to be 2. Then we just have to find our slope. Well, we just choose any random points that we want, any 2 points. 8 to 11, we'll add 3. 2 to 3, we add 1. Our slope is going to be equal to the change in y over the change in x, which is the same thing as our rise over run. Again, y's rise, x's run. Okay, so our change in our change in y was 3, and our change in x is 1. So our slope here is actually 3. So our equation for the table of values is y equals 3x plus 2. So again, y-intercept is going to be equal to when x equals 0, y equals what? That's your y-intercept. And slope, like we said, is just the change in y divided by the change in x. How do you get from one y value to the next? How do you get from one x value to the next? Divide, simplify. You're done. All right, now that we've done this, go ahead and practice workbook pages 93 and 94 for today. Have a great day. Bye.